It is my pleasure to introduce Mr. Aurgho Ghosh. Mr. Ghosh is the Senior Manager of VRV Business at Daikin Air-conditioning India Pvt. Limited. He brings over a decade of professional experience to his role. He is currently Administrative Head of Skill Development Entity at Daikin Japanese Institute of Manufacturing Excellence. Previously, Mr. Ghosh led the company's L&D vertical, and his focus was on a broad range of HR functions, from talent and organizational development to succession planning. Mr. Ghosh is a proponent for change management and diversity, equity, and inclusion initiatives at Daikin. His landmark achievement was launching DJIME's inaugural all-female batch, increasing female factory representation from 2 to 20% within 5 years, so showcasing his commitment to diversity and operational excellence. Today, Mr. Ghosh will briefly overview us about green refrigeration in HVAC systems. Please join me in welcoming Mr. Ghosh.
Very heartening to see his body of work in ammonia, and furthering the move towards greener refrigerants, especially low GWP refrigerants. I'll share my screen so that I can take you through my presentation. It will be a little different from what Mr. Anil showed, which was more, I think, bent on the industrial refrigeration side, cold rooms and storage of, meat and beverages. My presentation, whereas, would be more about commercial air conditioning and residential air conditioning, because that's though Daikin, of course, operates both in industrial refrigeration and commercial air conditioning. But for the sake of explaining to our audience what green refrigerants, what we mean by green refrigerants, I would want to focus more on the commercial air conditioning side of this presentation. So again, the topic, I think today's theme is about low GWP refrigerants, but we cannot talk about low GWP refrigerants in isolation. We have to talk about the entire ecosystem, of the different generations of refrigerants which have been used by companies, different substances, at what point of time, what substances were used, why they were phased out, why they were used, and what is the future of refrigerants in today's scenario. So if I think Mr. Anil did say that ammonia is not a new refrigerant, it has been here for maybe more than 100 or 150 years. So if you can see in this slide that there are 4 generations of refrigerants when we talk about the progress or the how refrigerants have evolved over the last 150 or 170 years. So the first generation of refrigerants included hydrocarbons like different kinds of hydrocarbons, propane, isobutane, butane, and also water was used as a refrigerant, carbon dioxide, and ammonia. Now, when the industrialization started in European countries and in US, and then into the other developing countries, what was required was a refrigerant which had all characteristics of high COP, high energy efficiency, but also had an equal balance of safety, reliability, and low flammability. Because once we moved into air conditioning of houses or commercial buildings, safety became a huge concern. So in the 1913s, what came into the limelight was chlorofluorocarbons, and later these refrigerants were used for a long time, but it was observed that these were ozone depleting substances. So we moved to hydrochlorofluorocarbons, and then finally we moved to hydrofluorocarbons. So both chlorofluorocarbons and hydrochlorofluorocarbons, because of the chlorine element, the chlorine element was depleting the ozone layer, which was in turn letting the harmful UV rays from sun reach the Earth's atmosphere and causing all kinds of diseases like skin cancer and melanoma. So these substances, as per the Montreal Protocol, were phased out, and hydrofluorocarbons, they gained prominence from the 1990s. As on date, again, let me try to tell you that my presentation is more about commercial and residential air conditioning. So, as on date, it is the most used refrigerant in residential and commercial air conditioning is R32 and R144A, which are hydrofluorocarbons, and they have zero ODP and very less GWP compared to their earlier predecessors. However, this was a part of the Montreal Protocol. Then the Kyoto Protocol happened, where it was mandated that we need to uh, produce substances which lower the global warming potential. And hence, now there is a new challenge as per the Kigali Agreement, which has been now ratified by all the development of residential and commercial air conditioning system. But let's see, what are the current refrigerants in use and what are the alternatives we have. And moving into the future, can refrigerants like ammonia, or can refrigerants like propane or butane, or even carbon dioxide for that matter, can they be used as natural refrigerants? Can they be used in typical houses or commercial spaces? So, as I said, the properties of first generation refrigerants, which were, as we say, natural refrigerants, be it ammonia, be it carbon dioxide or sulfur dioxide, I think they all had very low GWP. They all had high COP, high energy efficiency, high reliability. However, because they were flammable, because they could have a lot of fire hazards. Uh, when the industrial revolution started and more companies started adopting refrigeration in households, these were replaced by the second generation refrigerants, which are your trichlorofluoromethane or dichlorofluoromethane, which is R11 and R12, which Freon, which was invented in 1930, uh, which was very balanced in terms of their flammability, which was not non-toxic, and which had a decent level of COP and energy efficiency. But of course, as I said, that over a period of time, this refrigerants from the 1990s, when the Montreal Protocol kicked off, these were replaced by the third generation of refrigerants, which are hydrofluorocarbons like R134A, R404A, R410A, which are used even in VRFs and VRVs, and R32 refrigerant, which I am very proud to say it's a Daikin patented refrigerant, which is an azeotropic refrigerant, and it's today being used by most major companies in HVAC field for residential and commercial refrigeration. So we will speak more about R32, but before I come to R32, uh, what are the two phenomena which are a danger to our ecosystem? One was ozone, depletion, which was a major concern in the 1780s, and now the global warming potential. So, just for people who may not be from this world of HVACs or refrigerants, just a basic understanding: ozone, it's a triatomic molecule of oxygen. It's existent. There's a layer of ozone in the Earth's stratosphere, which is a protective layer. It protects the Earth's environment uh, from the harmful UV rays which are emitted from the sunlight. So this is a natural layer. However, over the last century, the chlorofluorocarbons and the hydrochlorofluorocarbons, they have been, when released into the Earth's atmosphere, they deactivate the ozone layer and hence deplete the ozone layer. the chlorine molecule. So these CFCs and HCFCs have majorly contributed to depletion of ozone in the last 50, 60 years. And that is why in 1987, in the United Nations Montreal Protocol, it was decided that these substances would be phased out. It was not to be banned immediately, but as per the country's development index, it had to be phased out by 2030 from developed to developing and non-developed nations. The second phenomena which was a concern was the global warming potential, which was not addressed in the Montreal Protocol, but later in 1997 in the Kyoto Protocol, this was a matter of concern. If you see from 1915 to 2015, the mean surface temperature of Earth has increased by 1 degree. And this is quite alarming because as a result of this 1 degree increase in temperature, there have been a lot of subsequent damages in the entire world. You can see glaciers are melting, sea levels are rising, the low-lying coastal areas are at a risk, and some places, especially places like Maldives, which are low-lying coastal areas, these will be completely submerged underwater if the global, if the total heat keeps on increasing. So, what is contributing to this global warming? They're typically greenhouse gases. Like carbon dioxide is a greenhouse gas. Uh, what it means is that when sunlight enters a greenhouse, it is trapped. A very very common example that you may see is that in a hot weather, if you enter your car, you will feel hotter than the outside. Why? Because the car is like a greenhouse, just trapped the heat. So the temperature of the car increases, and as compared to the ambient, it is higher than the ambient temperature. So these greenhouses are contributing. While my presentation is going to be a lot about hydrofluorocarbons, which have zero ODP, but unfortunately these substances are also contributing to the global warming. Unlike Mr. Anil's presentation, where he talked about ammonia, which has got very low GWP, even less than carbon dioxide, uh, hydrofluorocarbons have a certain amount of global warming potential. And so maybe in the next 20 to 30 years, these substances also will be phased out. But as we speak, we don't have any alternatives to hydrofluorocarbons in terms of safety, in terms of energy efficiency, in terms of reliability, and in terms of reducing the ozone depletion. So, what is GWP? What we call a global warming potential? It's basically the measurement of the amount of heat which is trapped by greenhouse gases, and it is the index is used as a comparison to the amount of heat entrapped by carbon dioxide. So, if carbon dioxide is one, any substance which has 100 GWP means it has 100 times heat trapping capacity as carbon dioxide. So, as I said, these are the two important protocols by the United Nations, one which concentrated typically on the ozone depleting, and the other which was on reducing global warming. Of course, then in 2016, the Kigali Agreement, following which all the nations, developing nations, have ratified this agreement. So, the HPMP plan states that by 2020, all developed countries had to phase out, and for developing countries like India, we had time till 2030 to phase out the ozone depleting potential substances. So, Daikin, as the leading air conditioning company in the world, we invented, or rather, we started using R32 refrigerant in the 1990s. But however, commercially it was made viable in 2012, and as on date, we manufacture all residential air conditioning units using this HFC 32 refrigerant. It is estimated showing by seeing the current trends of the ozone layer, which has started healing. It is estimated by 2050, the ozone layer would have healed completely. So that's a big step towards regaining our Earth's environment in terms of regaining the ozone layer. So just a comparative, the second generation refrigerants like R11 and R12, which was single component and largely responsible for ozone depletion, R11, R12, and R22. And the third generation, which are R410 and R32 refrigerant, which are now commonly used in most air conditioning systems. Uh, Daikin is uh, also the only company which manufactures both its air conditioners and refrigerants. So we have a refrigerant division which does its R&D on what green refrigerants we can manufacture. And as I said, that in the next 30 years there will be a alternative to R32 and R410. So the research work of that is already ongoing in our refrigerant division, and so that uh, it is equitably distributed amongst all stakeholders, Daikin has released the patents of R32. So today, R32 is not only being used by Daikin, it is being used by all companies, be it the Indian homegrown AC brands like Voltas or Blue Star, or the Koreans like LG, Samsung, the Americans, or the other Japanese, any top brand, they are all using now R32 refrigerant. Now, if you can see, uh, the chemical formula of R32 refrigerant is CH2F2, and it has zero ozone depleting potential as compared to R11 and R12 and R22, and there is no chlorine layer which is depleting the ozone. It has a GWP which is 675, much lesser than what we used to have with R11, R12, and R22, and still three times less than R410A. So a lot of commercial air conditioning still employs R410A, including Daikin. However, the global warming potential of R32 is one-third that of refrigerants like R410A. Now, this is a comparative of all previous as well as current refrigerants. So, if you talk of the refrigerants like R717, which is ammonia, or propane, or carbon dioxide, you see that they have all very high pressure at the condenser. That means they have very high flammability, which is a cause of concern. However, the GWP is quite low. Whereas components like the 407C or 410A, it has got low pressure at condenser, but a slightly higher volume capacity. The COP levels of these HFC refrigerant are at almost the same level of the natural refrigerants, higher than carbon dioxide, and the ozone depleting capacity, or the ozone depleting potential, except for R22, all the other HFC refrigerants, they have all zero, so they are comparable to the natural refrigerants. So the only concern which remains today is the global warming potential. This would tell you the comparison of these refrigerants vis-a-vis not only their GWP or ozone depleting potential, but also flammability. So if you see components like propane, it is highly flammable, or dimethyl ether. So these refrigerants are highly flammable. So all first generation refrigerants or natural refrigerants, they, while in industrial air conditioning or industrial refrigeration, in cold rooms, with proper equipment maintenance and with proper piping and proper storage, maybe they can be used. However, wherever there is mankind presence, it is important to see that what is the level of flammability, and the flammability of HFC 32 refrigerant is A2L. So it is mildly flammable, but permissibly flammable. Until unless there's a fire in the room, it is not going to break into an ignition. Apart from the 675 GDP, for reduced refrigerant charging, R32 refrigerant has a GWP of 472. So, as on an average, the amount of GWP that is being emitted by R32 refrigerant, when you compare the peak and non-peak condition, is around 472, which we are calling the modified GWP. So this slide will tell you that HFC32 is today the most balanced refrigerant for residential and commercial air conditioners as compared to all available refrigerants in terms of energy efficiency, safety, economy, and life cycle climate performance. However, as we move forward, since there is short of time, I'm just taking forward this presentation as fast as possible. As we move forward, we have seen the development of hydrofluoroolefins like H1234YF or ZE, which are used in car air conditioners. So, however, their compressor capacity is very low. So, can they be used in room air conditioners or building spaces? Well, maybe not yet, without increasing the size of the compressor or the rotation capacity. So, with that, I close my presentation. Thank you so much for your time and look forward to an interactive session. Thank you.
Thank you, Mr. Ghosh, for highlighting the significance of green refrigerants in HVAC systems.